This video will tell you some percentage application about the growth and depreciation. And in other words, you can say we will discuss something about the successive change about some values. So for the successive change, you can refer to increase or decrease for two cases. And so for case 1, which is the increased case, you can see if a value, the original value P, increased and the constant rate R%. Okay, so let's highlight the keywords for some periods, and then the new value will change after n periods, and you can get such formulas. And actually, I can just write down in a few words so you can think of it. This time we have an original value P, and that for each period the value will increase for R%. And so after some period, for example the n periods, here after n periods, and you can get the results of this formula. So you can think of it, the formula is a little bit similar to the compound interest formula. So if you understand the concept, you can easily to derive or understand the idea. So let me highlight this to you. And just one remark for this bracket, 1 plus R%, which is called the growth factor. Since you know that the value P is increased by the periods, so that the final value of A will be more than P. And that is the first formula. And similar to the case for decrease, and you will understand if this time P decrease also at a constant rate, which is R%, then after some periods you will know that the values will change to this P times 1 minus R%, the whole things to the power n. And also let's highlight the keywords. The 1 minus R% should call the decay factor. And also for the decay cases, that the depreciation is one of the application. Since we will know that for some products the value will decrease after some periods, and in detail we will call such phenomenon we call the depreciation, since the value of some products will decrease and we know this not good than the before. And okay, so just have a, if you will understand about the discount or the other concept, the depreciation are just the same. And here you can see for the depreciation, which is some kinds of decrease at a constant rate, so you can just highlight it. And also you will know that the depreciation actually just the change between the original value and the new value, and that you will understand the depreciation should be the original value minus the new value. And hopefully or mostly we want to understand the rate of change, so that we need to find out the depreciation rate, and that is just follow the percentage change formula. And you will understand that for the depreciation, which is just the change of value, and just put it in here, nothing new. Actually we have learned about the percentage change, so that we can understand this percentage change in here. And since you will know that for the depreciation it will appear more than one period, so that it is just the same formula as the decay cases. So you can make use of the examples to understand this. And okay, there are some formulas, and so let's have some quick examples to see how can we apply for the formula. Okay, the first example, we want to find the weight of John after 4 years, and you will understand the original value, which is P in here, and for the constant rate, that's our percent in here. So we can understand that the rate, we can just put in the formula, the original value. 1 plus, since this time the rate is increased, so you will understand that this time we'll use the plus instead of the minus, and then just put in all the values, and you can understand this. So you can just copy all digits in here first, and then to take the correct value, and okay, just write that correct to the nearest 0.1 kg, and that's the answer for example 1. And okay, so let's see some more cases about the decreased case, and this time you will understand. This time we want to find the volume of water in the pool after 6 hours, so that also you can see the volume of water will decrease at a constant rate of 10%, so that in here you will understand we should use the minus sign in our formula. And here you will know that for this is the P and use the R percent, and then we have all the things, and we can just put in the formula and we can get the answer. So that the answer should be 300 1 minus 10%, since this time 6 hours, so to the power 6, or I write better, this is 6 hours, this is the n, and that we can just write down the answer and correct our answer to the nearest 0.1 m cube. So just write down correct to the nearest 0.1 m cube, and that's the answer. And okay, just move on to one more examples here. Okay, put the frame much better in this way. Okay, so let's see one more examples in here. For the example 3, this time we want to find the new value of the watch be after 2 years. Since you know that this time the values will depreciate by 7% per year, then you can just apply the cases for the decay factor. The value is decreased for each period, so that just write down for the new value, which is just equals to the principal or the original value 1 minus 7%, and since we want to find the value after 2 years, and then we can just make use of the calculator. Oops, some mistake here, and then we can just find out the value should be 3495.6, and this should be the answer about the depreciation for the example number 3. And so the other problem, you can just refer to the formula and try to do it by yourself, and I believe you are able to get the correct answers.